All right, good morning, afternoon, whatever it is. So today we're going to go ahead and do section 8.4, part 1. And I think if I have this correct, only one class is going to be watching this on Edpuzzle, but the rest of you can watch this on YouTube or however else I'm posting it. All right, so as usual, if you're watching Edpuzzle, make sure you fill in the answers as you go. And I do look at them and I do grade them. And if you're watching this on YouTube, just go ahead and pause and make sure you give the answers before I give you the correct answer. All right, so pre-class, numbers 1, 2, 3, and 4. For numbers 1, 2, and 3, you just need to factor the expression. So factoring number 1, you should have got 5x times 2 minus x. So that's called GCF factoring. Number 2, I use guess and check method here. So I got x plus 6 times the quantity x minus 8. And then number 3, this was a difference of cubes, so you have to remember the formula. You might want to look that up. X minus 5 times x squared plus 5x plus 25. All right, what is the volume and surface area of a cardboard carton that measures the following? Okay, so the volume is pretty easy. 15 times 18 times 20, and we're going to get 5,400. For the surface area, all right, so you have a cardboard shipping carton. So you're going to have 2 that are going to be 15 by 18. You're going to have 2 that are going to be 15 by 20. And you're going to have 2 sides that are going to be 18 by 20. And then when you add all those up, you should get a surface area of 1860 inches squared, and for the volume, it'd be inches cubed. Okay. All right, so section 8.4, part 1. This is part 1 of 2 parts. We're just going to multiply today rational expressions. Part 2, we'll pick up and we'll divide rational expressions. So a rational expression is in simplified form if its numerator and denominator have no common factors. Key, no common factors. Therefore, we're going to want to cancel any common factors that we have. So in order to simplify a rational expression, we're going to follow the following property. So if A, B, and C are expressions with B and C not equal to 0, then the following property applies. We have A times C over B times C. Notice, the same factor, we can cancel, and we're left with A over B. So sometimes 15 over 65, you might need to factor first so that you can tell what the common factors are, therefore canceling them and simplifying. Again, you can do the same thing with binomials. You can only cancel an entire binomial here when it's multiplication. You can only cancel because there's a multiplication there. And we're left with 4 over x minus 5. So here's example 1, and we're going to simplify this expression. Now, step 1 in all of these problems, I want you to factor completely first. So the numerator becomes, in factored form, x minus 4 times x minus 4 over the denominator, which factors to x plus 6 over x minus 4. Now, once you've factored completely, you then cancel any common factors. You cancel 1 with 1. And then you write your answer with what's remaining. And that's it. Okay, so same steps. Step 1, always factor completely. Step 2, cancel common factors. And then step 3, write your simplified answer. Now, when are you possibly going to use this? Well, in business, you might want to measure efficiency. So manufacturers often package their products in a way that uses the least amount of packaging material. One measure of the efficiency of the package is called the ratio of its surface area to its volume. The smaller the ratio, the more efficient the packaging. I misspelled that. My bad, but it's all right. So for efficiency, we're going to take the ratio of the surface area to the volume, okay? The smaller that ratio, the more efficient. So example 2, a company makes kitchen canisters with the same base. Style 1 is a cylinder whose height is equal to its radius, and style 2 is a cylinder whose height is twice the radius. So for the first part, I want you to find the surface area and volume of each canister. All right, so for style number 1, the surface area is equal to 4 pi r squared. The volume is going to equal pi r cubed. For number 2, the surface area is equal to 6 pi r squared, and the volume is equal to 2 pi r cubed. All right, now find the ratio of the surface area to the volume. So basically, we're just going to be dividing these fractions over each other. So for number 1, when you divide, notice the pi's cancel, so you're left with 4 over r. For number 2, pi's cancel, you're left with 3 over r. All right, now, since 4 over r is greater than 3 over r, style 1 is less efficient than style 2. Okay, the smaller the ratio, the more efficient. Since style 1 had a larger ratio, it's less efficient. All right, guided practices. Okay, so again, I'm going to ask you to write your answer in Edpuzzle if you're doing this in Edpuzzle. If not, stop the video, try yourself, and look at the answer. All right, so number 1, x plus 1 is canceled, so you're left with 2 over x plus 3. That's it. Okay, number 2, step 1, what you should do is factor. So we have 20 times the quantity 2x plus 1 over 10 times the quantity x plus 3. And the only thing that cancels here is 2 goes into both the 10 goes into both 20 and 10. So we're left with 2 times 2x plus 1 over x plus 3. Now, you do not have to remultiply out. I don't want you to go backwards. So if you factored already like this to simplify, you don't have to remultiply out. All right, number 3, nothing cancels. It's simplified. 4 over x times x plus 2. Okay. All right, number 4. All right, so again, step 1, we want to factor. So the numerator does not factor. We have x plus 4. The denominator does factor. We have x plus 4 times x minus 4. The x plus 4 is canceled. Numerator, we're left with 1, placeholder, over x minus 4, and that's it. All right, number 5. The numerator factors x minus 3 times x plus 1. The denominator factors to x minus 3 times x plus 2. X minus 3 is canceled, so we're left with x plus 1 over x plus 2. And that's it. Number 6, we factor the numerator. We have 2x times x plus 5 over the quantity 3x plus 1 times the quantity x plus 5. X plus 5 is canceled, and you're left with 2x over 3x plus 1. And that's it for that one. All right, next concept here, we're going to multiply rational expressions. So what's cool is when we multiply rational expressions, it's the same thing that we do when we multiply fractions. We multiply across. Multiply numerators and you multiply the denominators. And then always simplify your answer. So multiply across A times C. Multiply across B times D. Same thing as shown here. You just multiply across and then simplify your answer. Now, true. If you're at this stage, notice that at this step, you could have done something called cross cancellation. So 2 went into 6 3 times. The 5 goes into the 10 2 times. You can cancel other things, and then you would be left with the same answer. So 2 ways. You can just multiply across and then simplify your final answer. Or you can cross cancel and then simplify your final answer. I like to cross cancel because that's, saves a lot of work. Okay. So here's example 3. So what I did with example 3 was I went ahead and I cross-canceled the coefficients. So 5 goes into 15 3 times, 3 goes into 27 9 times, and then 3 goes into 9 3 times. And then what I did was I just brought that down to 3, and I did x squared times x to the 5th, and I got x to the 7th, and y cubed, multiplied across. On the bottom, I got x to the 5th, and then y to the 5th. Now you could cancel, cross-cancel the variables as well if you're there. If not, you can just do this. All right, notice x's, 7 and 5, if I subtract them, I get x squared. 3 and 5, if I subtract, I get y squared. Notice it would be negative, so it stays on the bottom. And there's your answer. Okay. So example 4. So what I like to do in this problem, since we have some things going on, is I like to factor. So in the first factor, I have 5x times the quantity 4 minus x. Over here on the bottom, I have x times x minus 1 times the quantity x plus 4 times x minus 1 over, in the denominator, x plus 4 times x minus 4. All right, x plus 4 is cancel. X minus 1's cancel. X minus 4 and 4 minus x cancels. Notice they're almost the same, except for this is the exact opposite. When you cancel something that's the exact opposite, you need to factor out a 1, negative 1. And then x is canceled. And then notice the only thing that's left is negative 1 times 5. So that's how I get negative 5 as my answer. Okay. All right, example 5. So we need to factor. So we have x minus 4 in the numerator. In the denominator here, we have x plus 2 times the quantity x squared minus 2x plus 4 times the quantity x squared minus 2x plus 4. Those cancel. We're left with x minus 4 over x plus 2. And that is it. All right, and I think we're going to end here with some guided practices. So in number 7, you can cross cancel or you can multiply across, however you want to do it. Your final answer should have been x squared, y squared over 4. Okay, in number 8, remember you want to factor first, and then you want to cancel. And then your final answer should be x plus 3 over x times x plus 5. Here, you want to factor. This is the difference of cubes on the bottom. And when you do that and cancel, you're going to get x plus 5 over x minus 1. All right, I think that's it, right? Okay. So the key is we want to factor and then cancel. Okay. All right.